Thank you to everyone for coming along on such a cool night. I think it just demonstrates community support that frankly I don't think would happen in my suburb in Melbourne. Tonight, if I could have the first slide, Michelle, I'm going to talk about briefly about the fact that the climate is changing. I'll go through a number of slides. The slides will be available for anyone who wishes to get copies. And you might want to do that if I go too quickly through the earlier slides. Then I'll talk a little bit about what that means for this area, this region, some of the impacts, and then talk a little bit about uncertainty and risk management and building resilience. These are general messages about resilience development, but also specifically important to the management of the climate change issue. So these are the quick slides. The planet is warming. These are 4 different sets of data from different countries, all indicating the same thing. The Earth is warmed. It's warmed about 1 degree over the last 100 or so years. Next slide. We know why this is happening because we're changing the composition of the atmosphere with regard to what is referred to as greenhouse gases, particularly carbon dioxide, which is the top graph. You can see there over the last 2,000 years it was pretty steady, and then all of a sudden with industrialisation things have changed very quickly. These measurements are all measurements that were commenced when I was in CSIRO, and those measurements now continue. You can actually get up-to-date measurements on the website at Cape Grim in the northern tip of Tasmania, where these measurements are made for carbon dioxide every 2 seconds. And they're done 24 hours a day, every day of the month. Next slide. As a result of the fact that the planet is warming, the water in the oceans is expanding. And as a result of that, the sea level's gone up. There are other reasons, and I'll show you that in a moment, but that's actually been the main cause of the fact that the sea level for the world is now 20 centimetres higher than it was about 80 years ago. Next slide. But if you actually warm the Antarctica or Greenland, where the major terrestrial ice sheets are, that is the ones if you melt that actually fill the ocean basins up and make sea level rise, the other reason why sea level goes up when you warm the planet, then you can see this is what's happening in Greenland. Very special satellites. They fly in pairs around the planet, and depending on what they fly over, they come closer because gravity changes, closer or further apart, and this can be interpreted as the mass of water underneath the satellite. And you can see that the mass of Greenland is changing. Annual cycles, as you might expect, in the summer there's a little bit more, a little less ice, a little bit more in winter, but overall this reduction, which has now contributed about another 0.6 of a millimetre a year rise in sea level. But it's rising at the moment around about 3.5 millimetres a year. Next slide. The temperature is rising in Australia, pretty much the same as the global average temperature. Next slide. This slide's a little bit harder to understand, but if you take the left-hand panel on here, which are the maximum temperatures at a whole range of places in Australia, and you plot them all out, you'll find, as you might expect, that there is a peak where mostly the temperatures are, but sometimes they're cold and sometimes they're warm, and these are for the maximum temperatures. And if you can see that from the 1999 to 2000 period, going back to the 1951 to 80 period, this bell-shaped curve is moved. That's simply because Australia is now warmer than it was, but it's moved by actually a little less than a degree. But what happens is that changes the frequency that you get extreme events quite significantly. So the events that represent 2 degrees warming over the average in the past has now changed from something that occurred 2% of the time that now occurs 10% of the time. So one of the impacts of global warming is a change in extreme events, and we'll come back to that in a moment. The same sort of thing applies for minimum temperatures. Thank you. Seasonal rainfall. Now, I've got here only the wet season rainfall, because this is actually where most of the changes occurred. And you can see that our region here in southeastern Australia, rainfall is significantly lower than it used to be, and in the southwest of Western Australia. In fact, the changes in the southwest of Western Australia are near to the most extreme in the world at the moment, and changes in ocean temperature down the east coast of Australia. That is the southern part of New South Wales and eastern Victoria. The water temperatures in the ocean there are also some of the more extreme temperature changes in the world. And that's not because of the general warming, but the fact that the east coast currents changed. It's intensified, and they're the sorts of subtleties that occur when you start to warm the planet. You get changes in circulation of the ocean and the atmosphere. Next slide, thanks. Now this slide shows the black dotted line down the bottom is what's actually happened to the planetary temperature, now plotted on a much coarser scale. And then from now on, estimates of what will happen to the temperature of the planet as we go forward, globally averaged over the planet. And there are two sets, there's a red set and a blue set. And I wanted to show these because the reality is we don't know which set will occur. We have to look at the possible futures and say, well, if we do these sorts of things, then we might be able to maintain the temperature to the blue area, which is a warming from pre-industrial times of about 2 degrees, or it might go much more than that. That's particularly relevant today because the federal government's announced its targets for emissions. And those targets are based on the idea that the countries around the world have agreed that we really don't want the warming to go more than 2 degrees, which is really the same as saying we want to try to do no worse than following the blue line. And to do that is a huge challenge. As was pointed out by the Prime Minister when I'm coming up here today, listening to him speak on the radio, but many others who have different views about what we should be doing in this regard. And I'll come back to that in a moment. Next slide. Now, looking at what's going to happen, Australia is a huge continent, and so you can expect as you change the climate, what happens in tropical areas might be quite different to what happens in temperate areas like southern Victoria or Tasmania. And so the CSIRO and the Bureau of Meteorology were contracted several years back now to actually do a study where they tried to use the best knowledge they have at the moment, realising there are all things that we still don't know, to make estimates of what would happen for all the major land use areas of the Australian continent. So if you're interested in that, you can pick that up on the internet. Just Google, you can Google either the Bureau or CSIRO for this. Next slide, please. So what do we anticipate future changes for the Harrietville area and the surrounds? Next slide. So I need to remind you that there are a number of reasons why we don't know exactly what's going to happen. It doesn't mean we don't know anything, but we don't know everything we'd like to know. The first thing is that it does depend on what Australia and other countries do in terms of controlling emissions. It obviously depends mostly on what the US and China and India does, because that's where most people are and most of the emissions are, although Indonesia is also on that list of very important countries. But there are at least 50 countries that have emissions around the same amount as Australia. And if they all don't pull their own weight, we still have a problem. So it isn't just about those big countries. Everyone has to be involved in this. And as some of you will know, in Paris, later this year, there will be a meeting of the UN Framework Convention on Climate Change to try to decide how we share the burden of actually controlling the level of emissions of these gases into the atmosphere. And that's the reason why the government has now come up with this target. When they go to those meetings, they will then have to negotiate, and the target might go up or down. We don't know what will happen there. Certainly, they will be under a lot of pressure, I think, to make the targets more stringent than they have at the moment. But the first thing is we talk and use things about low emissions, medium emissions, or high emission scenarios, simply to say it depends on us as a global community which one of those we take. If we take the high emissions curve, it's almost certain we will have 5, 6 or 7 degrees warming. If we take the low emissions curve, we may be able to contain the warming to the 2 degrees. I can't spend too much time talking about the 2 degrees target because it's a politically based target. As a scientist, I think it's too much. But politically, that's what countries have agreed they'll try to contain it to. We must at least do that as we go forward. The second thing is, as all of you will know, the climate varies from year to year. So what I can tell you about warming of the planet, changes of rainfall and so on, don't apply to what will happen in any one particular year. We have to talk about averages over periods of time. We have good snow seasons, we have bad snow seasons. That will continue to be the case. The question, or all we can address in these kinds of studies, is on average, we're going to get better or worse snow conditions. The third point is that it turns out, a bit ironic really, that we can tell more precisely what's going to happen to the mean temperature of the planet than we can tell exactly what's going to happen to the climate in Harrietville. And that's because at those smaller scales, a whole pile of local issues come into play to affect how the global change to climate turns out to be. And these include things like geography, the fact that you're on either the western side of the barrier of mountains or on the southeastern side makes a difference to what those projections will deliver. How close you are to this East Coast current makes a difference to what will actually happen. And it also includes things like land use change. If you're actually changing the vegetation around, that also will actually interact with the overall changes to the climate. So it turns out, therefore, it's very difficult. In fact, it's impossible for climate science to tell you the difference between locations that are 50 or even 100 kilometres away. We can only give you aerial averages of those effects. The scientists themselves, of course, that's what they're doing. They're trying to work out better ways of actually making those projections more accurate, but also more regionally specific. And that's where the research is based right at the moment. So what are the direct climatic changes that we expect in this region? Well, most or highly probable we're going to get warmer average and extreme temperatures. For the reasons I showed you before, as we warm, we expect to get more extreme high temperatures and less extreme low temperatures as we go forward. This is a highly probable outcome almost anywhere in the world. It doesn't have the same kind of geographical concern or issue. But rainfall is quite different. The impact on rainfall in the tropical regions is likely to be a higher rainfall, because basically what you're doing is providing more energy in the surface, evaporating more water, driving more cloud formation. Whereas in these regions, if you think back to, and I'm going to my daughter-in-law's, I think class 4, grade 4, to talk to them in a week's time, they learn about as probably most of you do, you might have forgotten, that the tropics has this uprising air that carries all this moisture up with it and as it goes higher, it cools and the water comes out. And that air is therefore dry. And that air sinks in the middle latitudes, and where it sinks is where we have deserts. And we happen to be one of those areas by and large in Australia. That circulation is intensifying and moving slightly poleward. And that increased high pressure belt that occurs around southern Australia is the reason at our latitudes that rainfall in the winter that was dominated by these westerly systems that come across southern Australia, one of which I think we're going to get tomorrow, they're on a decrease. And in the southwest of Western Australia, very significantly, because they've lost more than a third of their rainfall in the southwest as a result of this. So it's highly probable that the winter rain will be lower, because that's what's happened. When you move these systems lower, then there's a probability that in the summer the tropical monsoonal activity will penetrate further south. And we don't know how far south. There's some evidence in the data already that summer rainfall has increased a bit. And so it's possible that we will actually have some increase in rainfall, but uncertain about that at this stage. The fourth point there is lower snowfall and persistence, and I'll talk a little bit more about that. This is highly probable. A change in the precipitation processes, but also the warmer conditions, changed seasonality that leads to less persistence of the snow on the ground. As you warm the atmosphere from below, it becomes less stable. Air tends to rise and fall in other regions, and that's what causes major storms. That's intensifying. So we're expecting, with quite probable outcomes for most areas, increased storminess. But it'll be greater. The probability will be greater if you're near the coast or regions where there's large amounts of heated water underneath you, which is a source for driving these storms. When you move inland, it's less so, and that's why it's probable and not very probable in this list here. Next slide, please. Requires a little bit of explanation, this slide. The top frame is really about what will happen at these areas, what we expect will happen in these areas. And you'll see that they're average over 30-year periods. So we get a central amount. And the reason for that is, as I mentioned before, things are very variable. And the only way of looking at them is to look at data averaged over a period of time. So the observations, which is the column labelled 1980 to 1999, these therefore are the 1990, based on the central date of 1990, the mean levels of the snow depths at these sites. And many of you in this room will know much more about this than I do. But when we then use different scenarios, because we don't know what humans are going to do, low, medium and high scenarios, then we can, in the top frame, work out what we think will happen by 2020. Not that far off. And that's what these say. So you can see uncertainty. There's a range of numbers for each of those little boxes, but they all show a decrease in the snow depth, even in this short period going forward. The bottom frame is then going to dates centred on 2050. So they're further into the future, where a greater amount of change has occurred to the climate system as we go forward, with low, medium and high projections. And so in that case, you can see that, for example, at Falls Creek, even with a low scenario, you're talking about changes of approximately half of the snow depth, average snow depth for that low level scenario. And for all of you who are in this industry, then you can read into that whatever you like. But it seems to me that this is a real risk for the industry in Australia, which some would regard as reasonably marginal anyhow. Next slide. So indirect changes occur in many different ways when you change the climate. Higher fire risk, that's a probable or very probable. I'll come back to that in a moment because it's very complicated, and there are I think emergency service people, at least in the audience. I want to go a little bit more detail into that. Higher energy costs is probable. Again, that's quite complex, and in fact that's where nearly all of my research is now, in energy futures. There are many things driving the cost of energy, the transition from the kind of energy sourcing that we have to the kind of sourcing we're likely to have in the future. Some of it driven by the climate change issue, but not all. Some of it's just simply technological change. Will make a difference to the price. It's probable that the price will go up. Most of these facilities don't seem to get cheaper. In this case, they probably will go up. Uncertain lower agricultural productivity. I rank this as uncertain because most people feel that the connection of agricultural people to climate is so close that they must be the sector that's most sensitive to a change in the climate. Well, actually, it's not really the case, because agriculture has by and large, a 1-year life cycle. If you're growing fruit trees, it's somewhat longer, but for most agricultural practice, it's short term, and you can change. You can modify what you grow, you can modify your practices, and you can respond to these demands fairly quickly. That's not the case for many other things, like the provision of water, say, where you have to build dams and pipelines and distribution systems and so on. The provision of power, where you have power stations that are built with at least 50-year life cycles, things like that, quite different from agriculture. So I think it's uncertain as to whether, because it'll depend on what part of agriculture you're in and exactly where you're located as to whether you can actually manage your way through that. Loss of the ecosystem viability, I think, is highly uncertain. I'll come back to that with another slide in a moment. And loss of tourism, partly because of concerns over the ecosystem viability, I think is also uncertain. But these are things that need to be on your list of issues to be considering. Next slide. This is the slide that I promised to say just a few words. It's quite complicated, and for those who are interested in the fire issue, you might want to come back to this. The problem with looking at bushfire risks is that it operates on a whole series of timescales. Climatologically averaged information really affects the development of fuel levels over quite long periods of time. But annual and seasonal effects can then actually strongly interact with the abundance of dry fuels and therefore high fire indices. And then what really does you in at the end is episodic issues. Higher storm levels, low humidity, high wind conditions that interact with things that have happened over the decade before. It's quite complicated. It's not easy to be predictive in terms of what's going to happen to the emergency services consequences at the end of this. All I think I can say is the likelihood of a drier climate is that we are going to have more bushfires, and there seems to be significant evidence of that already. Next slide, please, Michelle. So some key regional impacts. Next slide. This slide I did actually for the Treasury a few years back when they were, interesting side story here. This was when the current government was actually going to have a carbon trading scheme. And when they lost government, of course, they weren't going to have one anymore. But they needed the Treasury, who were planning the trading scheme, to try to understand what the risk was. in Australia. And this was an attempt to try to give them a feel for that. So what it shows up on the left-hand side is if you change the temperature by this amount, so many degrees, then for these different sectors, you go from a coping range, the green area, into an adaptive range where we think we could do stuff that would get us through those changes, into a red area where we don't know what we would do. And that's the dangerous area. And then it shows that once you get to 2 degrees, there are certain things like water availability, coastal communities, this the sea level problem, and natural ecosystems that take you into this red area. Part of the reason why people are agreeing let's not go beyond 2 degrees, because we don't know how to cope with that. The little bars on the side are a bit confusing, but basically the green bars and the yellow bars are the kinds of low scenarios that people are talking about. And they're talking about them because they are, on average, things that will bring us into about a 2 degree change, or we hope will, because you can see there's uncertainties on these things. It could be a bit above or a bit below. But it gives you a feel for the fact that there is exposure to all sectors of the society and societies. Those exposures will differ for people living here, living in Darwin, or living in Melbourne, or, for example, Canberra, where decisions are often made. Next slide. The one I want to do, and I already mentioned this to John before, is because while I've worked as a physicist all my career, which is now 44 years as a climate scientist, I was actually trained as a biologist. And so when I talk to my physics colleagues in the climate change area, and we talk about what risk are we really talking about here, I believe that my concern about the risk is slightly different from theirs, and this is because I know from my experience as a biologist that we don't know how ecosystems are going to respond. That is a risk. We don't know how stable the forests around here are going to be if they get burnt more frequently than they did in the past, or they're subjected to longer periods of drought, precipitation loss, or so on. Or if they're exposed to really stormy conditions that might change also the way they perform. Because ecosystems are very, very complex. Every one species almost always depends in some ways on the survival of others. And we simply, in most ecosystems, don't know how they'll respond. We will watch them as we're watching the fish ecosystems off the east coast of Australia changing quite rapidly. They're moving, the mixture of species is changing, and the fishes have had to move with them because they don't fully understand. It's not a very good situation to be in. So I think this, to me, is the risk, one of the risks for this area. You are surrounded by ecosystems about which we are not sure how they're going to respond to the sorts of changes I've mentioned. The impact of climate change on fire and emergency services can obviously result directly from the climate change itself, the frequency, intent, and intensities of emergencies. And I'm talking generally about emergencies, not necessarily just fire, although that might be a predominant interest here, but it can be floods, and it can be just storm damage. And those effects can impact on the capacity of a community to provide or deliver services, both in the cost and security of supply of energy and water associated with dealing with these issues. Next slide. This is a statement by the Australasian Fire and Emergency Services Authorities Council, which have said that the impacts on fire and emergency services sector of climate change will be immense. That is their words, not mine. They they talk about physical infrastructure to deal with extreme events when they occur. So part of the adaptation process is having the right physical and managerial systems in place to be able to deal with a changing degree and frequency of these kinds of events. That includes human resources to plan and respond to events, and also the changing risks to the people that are involved in providing those services, whether they again be fire, emergency services workers. And when you have fires, as many of you who will be aware, it's not just the firefighters. You have ambulance workers, you have the coroner, and you have the police, and you have a range of different services that have to actually come in and be involved, and they're all exposed to a changing background to those threats. Next one, thanks. And this is the way they see of addressing the risks, advocating at local, state and national levels for preventative and adaptive action. We're here because we want to know how to adapt to a changing world associated with climate change. But part of the way that these organisations can actually help is to also be actively involved in the preventative side. And this is both by doing things that lower emissions, but also acting in a way that helps the political process to deal with the emissions in the first place. That is actually the best way of getting through this. Adaptation is something we are going to have to do because it's too late to actually control all these changes. But we have to be constantly trying to mitigate as well so that the changes don't become too large. Commissioning research to actually understand some of these things better, and integrating climate change into risk management frameworks, into strategic planning, into resource planning and community education processes. So they're the sorts of things that the Australasian Fire and Emergency Services Authority Council see that have been needed. Next slide. I want to just say very briefly, partly because it's so topical today, when we have these targets released, a little bit about the targets. We have in Australia a climate change authority that is set up. It's very doubtful whether it'll survive too much longer. Politically, it's not desirable. But what it really is saying goes back to the original research we were doing in CSIRO 30 odd years ago. That is trying to understand the carbon budget, and therefore, in this particular case, how much can we put into the atmosphere in the next 50 years and then not get beyond the 2 degrees. And there are physical limits. These are not dreamt up. They actually are physical limits that we have to stay under. And we is the world. And so, firstly, there's this physical limit that says we can only put about another slightly less than 1,000 million tonnes of carbon into the atmosphere in this way. Otherwise, we're going to blow our budget. The second problem is who does it? Who does the reductions? And that becomes much more of an ethical problem. Do we have a responsibility, even though we're only about 1.5% of the global emissions, to do anything? Or do we freeload on the bigger countries and ask them to do everything? Next slide, please. Up until today, the current policy of both the major parties was a 5% reduction in emissions by 2020. And of course, the Climate Change Authority, which was set up to provide advice on this, said this is nowhere near enough and suggested 2020 target of 15% below 2000 levels and 40 to 60% by 2030 below 2000 levels. I don't want to go too much further on this but I want to just remind you when you're hearing this in the next few days is that a key factor is not the percentage reduction. That's important. The key factor is from what date. And they chose today to choose 2005 because that was the peak of our national emissions. So they chose the highest number so that they could actually get down to a reduction that is still a lot higher than it was late in the 1990s. Had they chosen as the Climate Authority to get a 2000-year baseline, which is what some other countries have done, then the number would have been much greater than the 28%, 26, 28%. So just be careful when you're hearing these things. There are games being played in these things. And there are games that shouldn't be played because these are important issues. And I'm not being parochial here because there are games being played by all sides of politics. Next slide, please. And the last thing I want to say on energy, because this happens to be what I'm really interested in, is a bit of a surprise. And that is, for the last 100 years, the use of electricity in Australia every year was higher than the previous year. Now, I think about anything else, whether it be the market or whatever it might be, things go up and down a bit. But for electricity demand in Australia, it's gone up every year for 100 years until 2005, 2006. Stopped going up and started coming, well, it's plateaued, but it's actually come down a bit. And there are a number of reasons for this. The main one is that there was regulation introduced for manufacturers of appliances in homes that required certain levels of efficiency. So it wasn't you or I going out and buying stuff because we go out and buy it because it's the right colour, it fits into this hole in the wall or whatever it is. It's because there was a regulation that says you can't emit in a dishwasher or a washing machine more than a certain amount of energy. It had a big effect. The introduction of solar panels had a big effect. The introduction of home insulation had a big effect, and this is a combination of all those things. It does show that coal has been on the decrease, gas has been on the increase, and hydro has been on the increase. And in this diagram, solar doesn't even appear, it's still so small, despite the fact that we have 1.4 million homes in Australia now with solar panels. That will start to show up very soon, but wind is already showing up in that diagram. So in a way, this is a good news because it shows that we can actually have a very significant change in the direction of these things that have been going on in the same direction for 100 years, very quickly. In this country, we have no legislation on the emission of CO2 from motor cars. Even the US has that. The average motor car in Australia emits around about 250 grams of carbon every kilometre you drive. The European standard is 113. Manufacturers can't build the cars if they exceed that on the average of the fleets that they produce. There are big things that we can do in this regard as we go forward. Next slide. So lastly, just a few comments about certainty, uncertainty and risk management. Next slide. We do this every day. When we drove from Melbourne today, there is a risk when you go out in the car and drive at 110 kilometres an hour, you're going to run off the road, hit a tree and be killed. And you're making an assessment all the time, almost every moment of the day, balancing the probability of it happening against the impact or the level of impact if it does happen. And these are two probabilities. And most of us are pretty lousy in dealing with probabilities. But that's what we're doing when we're managing risk. And with climate change, it's exactly the same. There's going to be some change. There's a probability that it'll be this extreme or that extreme. And then there is a magnitude of change, whether it be to fire risk, to the survival of species in the ecosystem or whatever, that has to be balanced. And we assess that when we're trying to determine what our exposure is in risk. This kind of model is used in businesses all the time, and many of you probably use the model yourself. The fact is that we have two opportunities to minimise the vulnerability that occurs out of that risk. One is to mitigate, to stop the emissions or slow the emissions, and the other major effect is to come in and manage by adapting to the changes that are going to occur. We have to do both. Next slide. So in a state of uncertainty, which some of the science it's where it is, as I said, with regard to ecosystems, we are not sure what's going to actually happen to those systems. You have to manage. You can't just throw up your hands and deny the existence. Well, you can. It's not a good idea. You have to retain a portfolio of options. You need to keep options open, and this is generally speaking about the management of any risk with uncertainty. Keep options open. Regularly review the policy and approaches in light of new knowledge. Very important part of this is, are you listening to people, whether they be economists, engineers, biological scientists, physical scientists, to the best knowledge before you make decisions? Most times that's not happening. And then reflecting simultaneous consequences for economic, society, and the environment. This is not just about building a better economy. It's about doing these three things simultaneously. Next slide. So finally, a couple of words on resilience. Next slide. Love to spend more time on this. Irene heard me speak about this whole concept of constructivism many, many times. But all of us do it because we don't have enough knowledge about the vast majority of the world we live in. We construct a view of what we think it is. And by and large, this is a myth. It's a myth that's based on what your parents told you, maybe your school teachers told you, maybe your religion told you, maybe your culture told you, and you hold on to that really hard. And if someone comes out and tries to tell you that actually the real world is different from that, there is a limit to how much carbon dioxide we can put in the atmosphere. For some people, that's a real challenge to actually make that. There are coping mechanisms we all use when we don't hear what we want to hear. And the most common one is to deny the existence of a problem or to avoid it. Denial is, I'm a climate skeptic. I don't think that's the case. Blame others is very common. It used to be blame the Chinese because they're the ones that are growing all the emissions. Probability, making risk assessments is poorly based, as I said before, because most of us have difficulty in putting those two probabilities together. So resilience approach, in my view, is one which must be applicable if matters do not turn out as you expected. Okay, you have to try to keep your options so open that if you are wrong, you haven't run yourself into a brick wall. That's a resilient situation. It has to be evidence-based. We are seeing a constant denial in our society of expert advice. We see committees being set up, built of people who we know are going to give a particular answer, the answer we want, and not necessarily experts. We have to be careful of that. It needs to be widely supported, public understanding. Groups like this group here, getting together and trying to understand themselves where they fit into the whole picture and what they can actually do. It has to be common to a broad range of political spectrum, practical and can be implemented. It's no good coming up with things that can never be implemented. There has to be an element of equitability in it, whether it be international or inter-community or between people. That needs to be there. And there are huge barriers to this sort of behaviour. One is the human behavioural issues that I raised before, the societal norms that exist, the way things were is for some people the way they should always be, institutional rigidities where we have in place political systems, economic systems that are very, very hard to shift, and knowledge capture. the way we are or are not investing in solid knowledge development. I think that's all now, Michelle, other than to say, here is a list in this set of slides, if you're interested, of websites that you can go to. These are particularly websites that provide sound scientific information about what we know and don't know about the climate change issue. If you read this stuff from newspapers, you will get quite a mixed bag. Some of it's rubbish, some of it's okay. Best to go to almost any of the international academies of science will actually have on their websites a presentation of the best scientific information. Some of those are mentioned here. Thank you very much.